All right. All right. So, like I said, I will talk about this factoring stuff here in a few minutes, but we're going to be doing some factoring the next couple of days for our homework and stuff. We're going to have a quiz on Friday. But let's go over Friday's homework first. Okay, so you had to tell me if it's a min or a max, what that min or max value was, domain and range, right? You didn't have to do any of the other stuff. So number 8 was a minimum value because it opened up, because our A value was positive, and that minimum value is -1. The domain for all of these is what? All real numbers, very good. And then the range, since it's a minimum, is y is greater than or equal to that minimum value, -1. And it's the y value of the vertex, remember. What you're doing is just basically finding the vertex so that you can answer the question. Then you can tell the range and min or max value. Number 9 is a max. Our A value is negative. The max value is 1/4. The domain, all real numbers. Range is y is less than or equal to 1/4. And number 10, the max value, it's a max again. That value is 20. And again, domain is all real numbers. Range y is less than or equal to 20. Anybody need me to do 8, 9, or 10? Yes?
I just have a question. Can we write it in decimal form on number 9?
Yeah, you can 0.25?
Yeah.
Yeah, that's fine. You can write it as decimal. I prefer fractions, but decimals is not wrong. And then we jumped up to 24. Did 24 to 30 even, right? Number 24 was a maximum value, 7/4. No, it wasn't. It was 25/4. That maximum value, which is 3.125. No, it's not 25/4, is it? It's 25/8. My bad. But the decimal is 3.125. Domain, again, all real numbers. Range, y is less than or equal to 3.125. 26, it's a minimum, and the minimum value is -1. Domain is all real numbers. Range is y is greater than or equal to -1. 28, it's a max. That value is 10. Domain, all real numbers. Range, y is less than or equal to 10. And then 30 was that little word problem about the temperature in Death Valley, and you were supposed to, it says what was the maximum temperature. So what you had to do is find the axis of symmetry, -b/2a, get that number, plug it in for D, and it said to the nearest degree, it was like 110.9, 111 degrees Fahrenheit. Any of those you'd like to look at? 24 to 30 even. Okay. I would like to look at 24 and do everything we did Thursday and Friday with number 24. Okay, just go through it again to review what we did. Okay? So, the first question you were asked to do what we started Thursday was if it opened up or down. So what about this one? Up or down? Down, because my A value is negative, right? Got a negative attitude, frown, right? So we're looking at this A value. What's my B value? 7. What's my C value? -3. Okay? So, the first thing we did, figured out opens up or down. Then we had to figure out axis of symmetry, AOS. Okay? Which is an equation, x equals, and the formula is -b/2a, which would be 7 for b, -2 for a. So that gives me positive 7/4 or 1.75. Decimals, okay. But again, I'm gonna use fractions, that's just because that's how I am. All right, C is looking for the vertex when we were doing these. And we already know the X value of the vertex. It's whatever we got for the axis of symmetry. When we take that 7/4 and do what on them? Plug it into the original problem, all right? So I put -2 times 7/4 squared plus 7 times 7/4 minus 3. Again, you can put all that in your calculator. That's fine with me. All right? So, -2 parentheses 7 divided by 4 parentheses squared plus 7 times 7 divided by 4 minus 3. There's your 3.125. That's fine. Or if you hit math and enter twice, it'll give you the fraction, 25/8. Okay? So answers we're looking for so far. That's the A answer. This is the B answer. This is the C answer. Okay? D was very simple. It was the y-intercept. Remember, y-intercept, the x value is always 0, and it's whatever our c value is. C is -3. So there's our part D. And then E, we're supposed to graph it. This was all the stuff we did Thursday. Okay, so axis of symmetry is 1 3/4. So I'll make that right there, supposed to be straight. Not too bad. Okay, and my vertex is 3.125 up there. So 1, 2, 3, a little bit above the 3. 7/4, 25/8, right? My y-intercept was 0, -3. And it's 1 3/4 left of the axis of symmetry. So I go 1 3/4 to the right, which is what? 1 3/4 plus 1 3/4 is 3.5. Is that right? About right, huh? All right, so that's 3.5 -3. So there's my parabola that opens down. Okay, and then Friday's stuff, what we added to this, okay, I guess we could call it F. It's a max. And what's the maximum value? Well, it's only the y value. So it's just the 25/8 or 3.125. Then domain, if we go G, domain and range, domain is always all reals. And range, since it's a max, y is less than or equal to whatever the maximum value was. So that was everything from Thursday, Friday, putting it all together. Okay? Any questions on any part of that? You guys follow? It seems like it takes a while, but it's not that hard. It does take a little bit of time. but it's not that hard to do. Okay, so today, again, these are called quadratics, right? Quadratic functions. We always have an x squared in here, right? So we're going to solve quadratic equations and quadratic functions by graphing and factoring, okay? So that's what we're doing today. And this part, determine a quadratic function from its roots. That's what we'll do tomorrow. That's going backwards. So what we're going to do is solve today. Tomorrow we'll give you the answers, and then we're going to go back to the equation. We're going to figure out what the actual problem was, okay? That's what we're doing. So going back to this, steps in factoring this is my thought process. If I have to factor anything, first thing I always think about is if I have a GCF in the problem. Hi, Hunter.
Hey.
Thanks.
Yeah.
All right, a GCF stands for greatest common factor. What? And you're going to have either 2 terms or 3 terms or 4 terms for your quadratic, which quadratics usually only have 3 terms. But sometimes they'll have 2 terms. And sometimes we'll turn them into 4 terms. Okay? So we're looking for what's common to all 2 or all 3 or all 4 terms. All right? If there's nothing common, then I think to myself, is it a difference of squares? Okay? By squares, I mean perfect squares. Difference, I mean subtraction. So difference of squares is a binomial, only 2 terms. They're both perfect squares, and it's subtraction. Like x squared minus 9 would be an example. I got an x squared, which is a perfect square. I got a 9, which is a perfect square, and minus 2. Okay, any variable to an even power, to the second, fourth, sixth, eighth power, is a perfect square. The next thing I look for, if it's not one of those, if it is one of those, then I go ahead and factor it. I'll show you how, if we run into one. Next thing I look for is called a sum or difference of cubes. Also, binomial, 2 terms. They're both perfect cubes, like x to the 3rd power, or x to the 6th power, or x to the 9th power, any multiple of 3 power. Okay? It could be addition or subtraction, and then the other number has to be a perfect cube. Like 1 cubed is 1, 2 cubed is 8, so 1 and 8 are perfect cubes. 3 cubed is 27, so 27 is a perfect cube. 4 cubed, 64. So 64 is a perfect cube. If you're not sure if a number is a perfect cube, if you go to math on your calculator, number 4 will take the cube root of the number for you. That little 3 in front of the radical there means cube root. Okay? All right? If it's not one of those, then I look at it, it's probably got 3 terms. And then I look to see if it's one of the, I call a trinomial square. Sometimes they call it a perfect square trinomial. And what happens here, it's got 3 terms, that's why it's a trinomial. Then the first and the 3rd term, my A and my C basically, are positive perfect squares. Okay? And then there's a certain way that we factor them. If it's not one of those, it's what I call a regular trinomial. It's got 3 terms, and it looks like your basic quadratic. Ax squared plus bx plus c. If a is 1, it's really easy. If a is 2 or bigger, then I got to do some more work for it. And then 6 I call the grouping. It's got 4 or more terms, usually just 4. We don't usually go past 4. All right, and then you're always supposed to make sure you factor completely. Okay? So that's my thought process. I guess that doesn't go. Move up. There it goes. All right, so just that's how I think through a factoring problem. Okay? That's my thought process. So some people, I don't know what kind it is, when to do what. So that's why I go through this order every time. Then I know what to do. If I eliminate that, then I know I go to the next thing. If that's eliminated, I just keep going down. If it is one of those, I stop and I do that. If it's one of these, I stop and I do that. Okay? All right, so let's look at, again, zero and a root of a function. You should know, guys already know this. Binomial has how many terms? And trinomial? Okay, you're so smart. All right, so a zero of a function is a value of the input, the x, the domain. All right, that's what we call the x values, the domain. That makes the output, f of x, the y value, the range, equal to 0. The zeros of function are the x-intercepts. Okay, where the graph crosses the x-axis. So these two spots are called the zeros, the x-coordinates, whatever the x value, because the y value is always what when you're on the x-axis? 0, right? That's why they call them the zeros, right? When y is 0. Unlike linear functions, which have no more than one zero, quadratic functions can have two zeros, as shown at the right. These zeros are always symmetric about the axis of symmetry. They're the same distance from the axis of symmetry. Okay, sometimes this parabola is moved up above the x-axis. Does it have any zeros then? No, because it never hits the x-axis. So it won't have any zeros. Okay, sometimes the vertex will be right on the x-axis, so it only has one zero. So it could have 0, 1, or 2 zeros, depending on what your graph looks like. So we could just graph, a parabola. Let's just make one up. X squared plus 4x plus 3. That's a pretty easy one. There's my parabola. These two spots where it crosses the x-axis are my zeros. They're actually -1 and -3. Okay? If I go to my table, second graph, and go to -1 and -3, what do you see in the y?
Zeros.
You see zeros. Those are my two zeros. That's doing it graphically. Just put it in the calculator and look at it, see where it crosses the x-axis. That's easy, right? Questions? Okay, so again, what I do, put it in my calculator. Whenever you want to graph something, you have to get y by itself. You have y equals button. You plug it in, the y equals, hit enter, and then hit graph. It'll graph it for you, and then go to your table, second graph, and look to see where the y column has zeros. Your answers are the x numbers. The x values, see? The x coordinates. Okay? Any questions on that? Okay. Drake, you good? Good. All right. Again, any points with the same y value are symmetric about the x-axis for all parabolas, for all quadratics. Okay, you can also find zeros by using algebra. This is where the factoring comes in. For example, to find the zeros of f of x equals x squared plus 2x minus 3, you can set the function equal to 0. So that's what we always do, is set it equal to 0. And then we factor it, okay? The solution to a quadratic equation of the form ax squared plus bx plus c equals 0 are roots. So if they ask you for the zeros or the roots, they're asking you to do the same thing. You'll see both of those. It'll say find the zeros, the directions, or find the roots. You're doing the same thing. All right? Roots and zeros, same thing. But don't get confused. All right, you can find the roots of some quadratic equations by factoring and applying the zero product property. Again, functions have zeros or x-intercepts, equations have solutions or roots. All four of those mean the same thing. X-intercepts are roots, x-intercepts are solutions, zeros are solutions, zeros are roots. Okay? If I were to multiply two numbers and the answer is 0, what must be true about one of the two numbers? The answer is 0, and I'm multiplying. It has to be equal to what? One of the numbers has to be 0, right? In order to get 0 if I'm multiplying. Okay? So what we're going to do is we're going to factor, and we call numbers we multiply, we call factors. So in order for one factor times another factor to be 0, one of those factors has to be 0. Okay? So that's what we're using. We're using this zero product property. Okay. So, example. A lot of talking. Okay? Is there a GCF? I'm factoring. I'm going through my list, my thought process. Is there something that goes into all three of those terms? Besides one. No. Is it a difference of squares? Does it have two terms, both squares, and a minus between them? No. Is it a sum or difference of cubes, or is there only two terms? No. Is it a special trinomial? Is the first term a positive perfect square?
Yes.
Is the third term a positive perfect square? So it's not one of those. So it's number 5 on your list. It's a regular trinomial. What's my A value? 1. What's my B value? -4. What's my C value? -12. These are really, really simple when my A value is 1, like this one. So set it equal to 0. When A is 1, you can go right ahead and make 2 sets of parentheses for 2 binomial. The only way to get x squared is what times what? X times x, right? So x goes in the front of both of these. Okay? All I worry about is the C value. And I think about what times what is -12. Those are the factors of -12. So I could have -1 and 12, +1 and -12. I could have -2 and 6, or 2 times -6. I could have -3 times 4, or 3 times -4. All of those multiplied give me -12, right? Then I look at them, and I look to see which pair, when I add them, give me the B value, -4. Which pair is it going to be? That's -1 when I add them. Yeah, 2, -6. When I add those, I get -4, right? So when I factor this, it's a +2, so +2, and a -6, so -6. That's a regular trinomial, easy problem to factor. Now, I'm not finished. I'm looking for the roots, the zeros, right? So, remember what I just said. If something times something is 0, one of these somethings, one of these numbers has to be what? 0. So what we do is we go x plus 2 equals 0, or x minus 6 equals 0. And then I just solve for x. Those two answers are my 2 zeros. If I were to graph this on my calculator, my parabola would cross the x-axis at -2 and +6. Okay? Questions? You guys are awful quiet. Some of you are zoning out. The golden tones of Mr. Mattingly are putting you to sleep. That lunch in your belly, full belly, making you sleepy. It's a warm, beautiful day. Questions? We okay? All right. What's the first thing you do, Isabella, when you factor? Look for? All right, is there a GCF for this?
No.
No. Look again. You're so smart. First of all, we do this, right? Set it equal to 0. Again, you put the 0 on the other side. That's fine. Doesn't matter. But 3x goes into both terms, doesn't it? Isn't that a common factor to those two? So here's what I do to finish it up. I divide the 3x, the common factor, into each term. What's 3x squared divided by 3x? 1x, right? Or just x. What's 18x divided by 3x? 6. So if I started out with two terms, a binomial, then my parentheses should have two terms, a binomial, when I take out the GCF. Okay? What if this was 3x squared plus 3x? What would be there? A 1. A lot of times kids say, well, 3x and 3x kind of cancel each other out. They don't put anything there. You've got to put the 1 there. Okay? Got to put a number there. Okay? So now what's next? What did I do with those?
Find 0.
Set them equal to 0. So I do that with these two. I go 3x equals 0. Those are my two factors. Or x plus 6 equals 0. And I solve for x. So 3 times x means I got to divide by 3 to move the 3 over. What's 0 divided by 3? 0. And here, subtract 6 to move it over to get x alone. 0 minus 6 is negative 6. So there's my two zeros, my two roots. If I graph it, it's going to cross at the origin and negative 6. You know, if I do a quick sketch, it's going to look like this. How do I know it opened up? A was 3, right? What was B? 18. What was C? 0, right? That's my y-intercept, isn't it? 0. Right across the y-axis. Everything matching up with what we've been talking about? Making sense? Hannah, you okay? Questions?
Yes, sir.
All right. So, what do you think, Garrett?
Working on the terms I'm going to.
Yeah, is there a GCF?
Yeah, there's none.
None.
Different terms. This is the part I get confused
Well,
on.
difference of squares and sum of difference of cubes have only how many terms? 2. So those get eliminated right away, right?
Yeah,
When you got 3.
the special trinomial.
Is that a positive perfect square, that one?
No,
No, so it's one of those regular trinomials. What's A?
X squared.
1x,
1, right? What's B?
negative 5,
And C?
negative 6.
All right, so we're gonna factor it as a regular trinomial. Right? What times what is x squared? X times x, right? Got 'em?
Do you so what happens if we forget it's like a special trinomial and we just factor as a regular?
It'll still work. Good question. If you miss it, it's a number 4 if it is, and you go down to number 5, you'll still get it. It's just a little quicker if you recognize it, that's all. Okay? So, Negative 1 and 6, 1 and negative 6. Negative 2 and 3, 2 and negative 3. Which pair of those add up to negative 5? 1 and negative 6. Very good, Jer. Right, Nate? Positive 1, negative 6. When I multiply those, I get negative 6. When I add those, I get negative 5. So Grace, now what?
Equal them to 0.
Correct, set them equal to 0. And again, once you guys start doing this, you're going to be able to, once you got it here, you're going to be able to tell me what the two answers are, right? What's this answer? 6. What's this one? Negative 1. Making sense to you? Again, if you get stuck, to help you, what could you do?
Put it in your calculator.
Yeah, just put it in there, right? What is it, x squared minus 5x?
Yep.
5, 6. Okay, go to my table, second graph. I got a 0 at negative 1. So that's the one on the left. And there's a 0 at 6. So if you're getting stuck factoring, you could look at the graph to help you factor.
Why don't you use that anyway?
Just giving you a few hints. What's two answers? Should be able to tell me right now. What was one of them? 8 was one of them. No, 8. What's the other one?
1.
Nope. No. 2. No.
Negative
4.
4.
7.
2.
23.
Wow.
8.
Here's the 8. What's that one?
1.
No.
X.
Negative 1.
Robert? 0.
That's right.
That's 1.
No, what are you supposed to do with the factors? Set them equal to
0.
So you would write this, and you would write this. What's that saying?
X equals 0.
The same one? No.
Zero.
Okay.
You gotta be smarter than that.
Okay? All right, good job today. There you go.
Good work.
Yeah, you get lots of it. Look at all this. 2, 4, 6, 8, 10, 18, 20, 10 problems.
8.
All right, so, when's our quiz?
Friday.
Friday. Friday, yeah. Never heard of Friday?